Why is frequency modulation, FM, used for signals? Imagine trying to listen to your favorite radio station on a stormy day. The sound is clear, and the music keeps playing without much interruption. That's because of a special way signals are transmitted called frequency modulation. But why do engineers prefer this method? Let's find out. Frequency modulation is used mainly because it makes signals much more resistant to noise and interference. When signals travel through the air or cables, they often pick up unwanted noise. Most of this noise changes the amplitude or strength of the signal. But in frequency modulation, the information is carried by changing the frequency, not the amplitude. So, noise that affects amplitude doesn't mess up the actual message. This means clearer sound and data, especially in places with lots of interference like city areas or mobile networks. Another reason FM is popular is because it allows transmitters to use nonlinear power amplifiers. These amplifiers are simpler and cheaper because they don't need to keep the signal's amplitude steady. Since FM signals keep their amplitude constant, they can be amplified more efficiently, saving power and reducing costs. This makes FM transmitters more reliable and easier to build, especially for broadcasting stations. FM also keeps the waveform steady during transmission. This reduces distortion, which is when the sound or data gets warped or unclear. That's why FM is often used for high-quality audio broadcasts, like music or voice transmissions, where sound fidelity really matters. The stable amplitude helps preserve the original quality of the sound from start to finish. Even though FM needs a wider bandwidth than amplitude modulation, it makes up for it with higher quality and capacity. This extra bandwidth allows for better sound quality and more channels, which is why FM is the go-to choice for radio stations that want to broadcast music and voices with clarity. In control systems and analog signal processing, FM's way of changing frequency according to the signal's amplitude allows for precise reproduction of signals. This is useful in recording equipment and measurement devices where accuracy is key. FM can also handle low-frequency signals and direct current levels better than some other methods. To sum up, FM is used because it resists noise, allows efficient transmitter designs, provides high-fidelity sound, supports wider bandwidths, and ensures accurate signal reproduction. These qualities make it a top choice in many communication and signal processing applications.